Alright, so I'm not going to be doing too much tonight. I've got a bunch of stuff I'm working on for another video regarding Soundly's water tower observation. I didn't mean to spend so much time on that particular observation, but there's a lot of stuff going on that I didn't really see at first, and I think there's a lot of evidence here that this observation would be impossible on a globe. But I have to basically go through my numbers again, which I might do at some point tonight, but for now I just want to get these this tower model going, and then I can use it to locate the position of the three lights that we're seeing in Soundly's video. So not sure why my stream says low output. Check it in a bit, but it's kind of weird. I don't have that much open. Okay. See if that works. Get rid of this. So this is 60 meters, I think. So what I probably should do is make it even 100 meters, and then it's easy to scale either way. So that would be 28.5 by 100. Seems about right. Alright, so now what I'm going to do is add a light to this. Actually, it's probably not good to use an actual light because we don't need it to be casting light on the scene. I think if I just make a just add a sphere. Alright, now we just need to make it blink, just because we can. So we'll just go into our event graph and use a tick event. Actually, we'll just make a function and call it on a timer. So call it trying to figure out the best way to do this. It's fairly simple, but because I want the light to flash for like half a second and then be off for a couple of seconds. So actually, let's try using a timeline. I have to kind of refresh myself on how to use them anyway. So might take me too long to figure out again. Just kind of doing this to kill time until anybody shows up in the chat. Oh, there's not too many people on YouTube. Saturday night. Okay, so let's do this another way then. Hopefully this works. Cool. Flashing radio tower. it's really weird that it's a certain distance. It's rendering, but not every time, and it kind of renders a little bit differently. I guess that's because of the variableness of the fog. It's kind of cool though, it's very realistic. If you watch Soundly's video, that's actually exactly what's happening. There's certain times when you don't see the light flash, and other times when you do. Be back in 2 minutes. Alright, so I'm gonna do a little sneak preview of what I'm working on for Sally's observation. Just share my screen here. So, I haven't done an updated rendering of the water tower at different heights. I've only got the 50-meter observation in here right now, but basically I matched up the scale using the two towers that I found on Google Earth within the viewing range here. I narrowed down the viewer position to within a few meters on the hotel, left or right, and basically using where the line intersects here and where it intersects here roughly as a guide. And then I was able to verify that distance with this and this distance between these two towers. And basically it works out almost to the pixel for that, and then the water tower to this works out within about 10 pixels, so a little bit of discrepancy there, but I'm going to show all that in my video that I'll probably get out tomorrow. It's looking like, and I'll just show on Google Earth the other things I've found. So I marked out all the sheds so I have an easy reference, and then the hump locations and everything just for lining up my lines, making sure they intersect at the right places on the photograph, and so far everything's very close. So we had our original tower here. Where is it here? Alright, so we have this tower here, which is the tower that's in question. Right now I've got it between the lines just because I was trying to see if it was possible that we were seeing the further back tower, and at this point I don't think it is, but I just want to show what that tower looks like because I found it really interesting that they're both in almost exactly the same line of sight. This one's just a tiny bit further out this way, but again, it depends slightly on the exact viewing angle from the hotel window, and believe it or not, it does make that much of a difference when we're looking at something that far away. So this is what this tower looks like, and it's definitely smaller. I don't think that's 20 meters across, but it does look a little bit higher maybe, but it could be an optical illusion because there's nothing tall directly around it. So if anything, if these two towers do happen to be in exactly the same line of sight, then chances are, even on a flat earth model, we wouldn't see this tower even if it was a bit higher, because it would be slightly further back. And I can't quite see, I'll switch back to the photo here, but I can't quite see the closer tower if we were seeing the further back tower. Yeah, I can't see this being that tower as far as the angular size go. It doesn't really work either unless it was being really magnified. And the closer tower would have to be somewhere down here hidden, and there's no real evidence of that. So for now, we'll stick with the assumption that this is the close tower, and I'm still going off the 20-meter width for this, which works out to 57 pixels. I'm just going to double check that right now. 56 pixels, yeah. So I have to put in the exact line on here, and like I said, it's just a tiny bit off the scale from this tower. But when I do the pixel measurement for the entire width of the image, we get the same pixel value for the distance between this tower and this tower. And I guess I better show those now too. So those are go back to that. Tower 1 and Tower 2. I've gone down to street level all around here and just made sure that there's no other tall towers that we could be mistaking these for. You know, and judging from the shadow length, they're considerably taller than the water tower, which was 51 meters, 52 meters, something like that. And the other tower just off to the side of it, where did it go? Right here. Seems to be even slightly taller than this tower. Not by much, but by a small amount. And if we look in the photograph, what we're seeing here, the height difference between this, you can't really tell in the video or in the still image. Oh, I'm not sharing. In the photograph, so this would be the further tower on the right, and the tower on the left. You can see a light flashing here in the video, but it didn't capture it for this still frame. So one thing I could do is try and confirm the height difference between those two towers, make sure that those are in fact the towers. And then we have this light up here, which I've narrowed down. I've pretty much combed the entire area between our field of view lines. And if we go way back here, so this is the width of the area we're seeing in the photograph. Oh, wrong way. And this is the only tower I could identify. It's a very narrow tower, but as you can see by the shadow, it's very tall. I can go back. I wasn't able to find a shadow that I think I could accurately measure with the sun angles yet. It's really hard to tell with the trees, but it's definitely a considerably taller tower, so we might be able to find out some information on this actual tower and get the height location of the light, and also notice that it's up 9 meters. And when I run this line back to our observer location, it works out to exactly, oh crap, wasn't sharing. Okay, I'll do that quickly again. So Google Earth, so we go way past these two towers. Now we're out here at about 53, 54 kilometers away, and we have this tower, very large, or very tall, skinny tower with a light on the top, and judging by the shadow, which I was just showing, there's no real clear indication of where the shadow ends on any of these images, so it's going to be kind of hard to get the height, but I definitely think that's the tower that we're seeing, or the light that we're seeing. And when I go back to the photo editor, the line on Google Earth comes through exactly, intersects this point on the bridge. So I don't think there's anything else that could be. And the final thing I'll point out that I want to put in my video tomorrow is back to Google Earth, and so we have the far tower. So I just made a polygon shape to show the elevation, and this is at 10 meters. So I just want to show that there's no land in the immediate area that we're seeing here that is above 10 meters. And actually most of this, I don't know if you can see this on the screen over here, but you know, everything's around 3 meters, 4 meters, very low elevation. And judging by the tree heights, well, basically I'm going to have to show that the land we're seeing represented from here to here in the photo would be too much for what we would expect to see on a globe. Not by a whole lot, but by a noticeable amount, I think. And then I'll show the position of the tower on a flat earth, which doesn't work 100% at this point either. It needs to be slightly compressed or slightly lowered in its actual position. But I'm going to do side-by-side comparison and kind of talk about the difference that refraction has to make up on either model, and which model requires less abnormal conditions to make it work, basically. Nobody in the chat? Okay. And we'll keep going with this. So what I've got here too is I identified the furthest shed that we should be seeing to the bottom of the pillars based on 50-meter observation height. And that would be this one, the 13th. And I counted back from this being the 4th shed, 3rd shed, and then there's 2 more until the shoreline. And there's 14, 15, 16, 17. There's actually 19 sheds, I believe, total. So 2 are obstructed from our view at this angle, but this hump corresponds, this furthest back hump here corresponds to right after the 13th shed. So this is basically blocking the last couple of sheds, and we're seeing inferior mirage going on here a little bit anyway. But like I said, this sort of barrier thing extending from the bridge here would actually be starting right here. So it's kind of like we're seeing these pylons through it. Yeah, it's kind of creating that illusion that they're going down behind it. So I'll be showing that, and then I'll show where it would be on the flat Earth model and where our ground level would need to be is basically close to where the horizon is. But like I said, if the top of this image is being projected down or the image is being squished, our actual ground level for the tower could be slightly higher here, and as you can see, that's a lot less difference for how much it needs to move than on the globe model, because that's just putting it at the height of the I could probably make this a couple pixels bigger too, to be totally fair. It's a little bit smaller than that one. I'll just do that right now before I forget. Close enough. Anyway, so that's what we'd be looking at, but then we also have to take into account, you know, for example, this could easily have moved by that much down. Still looks a tiny bit small, but put it right over the globe one and see. These guide snapping is annoying. Anyway, it's close enough for now. So, you know, this would be the ground level here. But like I said, it would be fairly close to there anyway. And then of course the actual horizon would be up here, eye level would be up here, and this horizon that's drawn into the rendering here is drawn to a distance of 100 kilometers, so obviously we wouldn't see anything, you know, just through the density of the air past probably 50 kilometers or so. I mean, we're not seeing that tower or even any shadow of the tower. We're only seeing that light, and that tower is at about 53 kilometers, so of course we wouldn't see this land, but it does kind of correspond to, you know, what we're seeing below this tree line. So yeah, definitely lots to consider for this observation, and I think that it's a good one to kind of keep working at, keep getting more accurate values for the heights of everything, and the exact location. How do I get this to not snap? Anyway, I think the eye line makes a lot more sense too. I don't think, I mean, this is the eye level line again if we're on a globe model, whereas this is eye level. We're basically eye level with the top of this tower, roughly at 50 meters, which makes sense. So I think I covered pretty much everything there. It would be awesome if Flat Earth actually ends up going there and doing some observations, because, I mean, Soundly's done a lot of observations, but I don't know, there's a lot of distrust in the Flat Earth community about his work. I personally don't think he's lying about anything or, you know, being purposely deceptive about anything. I think he honestly believes his images do show evidence of curvature. But yeah, basically there's still discrepancies in his observations that don't match the globe model perfectly, and they don't present atmospheric scenarios that support those observational differences. All right. Oh, hey, Cinnamon Control. How's it going tonight? Like my new creation. Just made a radio tower. Yeah, I haven't been doing too much. I just kind of went over some stuff I'm working on for another video about Soundly's observation. I don't really know why. This observation got so much attention lately. I guess it was from Flat Earth Perth's video, but you know, it's been around for a while and there hasn't been much talk about it either way, because basically all it shows is something that looks like curvature, but there's no actual claims of anything being obstructed by curvature. which I was just kind of showing. Yeah, I was just showing because I identified the tower here and the tower, this tower here, and there's another very distant tower that produces a flashing light in the video. And I triangulated everything, did all the pixel calculations, and basically these are the only 3 towers it can be. So based on that, I'm going to try and model as much of this as I can. And I think the other thing I can do is make I should be able to make a simple model of the shed at least. I don't need the road, like the whole bridge and everything, but at least if I get the sheds in, then I can kind of show. I mean, obviously Walter Bislin has this all modeled out in 3D and like a simplified sort of wireframe thing. But I think if I can do the same sort of thing, just using basic cube shapes for these, and then I can yeah, just show the difference on globe and flat and see if I can reproduce this sort of effect on a flat plane. In what direction is the water tower off? So basically lining up the horizon with like, do you mean on the globe or on the flat model? Because on the globe model, our horizon should be here at the base of the 13th shed, which is 25 kilometers away, just a bit further, but that's where our 50-meter observer height puts the horizon line at. So if I line that up, this could be, you know, a tiny bit higher, I guess. And then we have the globe here, and it should be up here. And yeah, this line's a little bit wide right now. Based on the pixel scale between the 2 towers, and then verified by the angle at the extreme of the left and right of the image, I got it pretty close to this. Should be, I think, 55 pixels. Oh, 53. So that's what the globe model should look like, roughly, within a few pixels. And the flat model, if I put it roughly where it appears to be in the image, then the base of this should be somewhere about, well, it would be about here. Actually, no, it would be 5 meters lower than that, I guess. And this horizon line on a flat model is just land drawn to 50, no, sorry, 100 kilometers away. So this is the eye line, eye level line, zoomed in. And comparatively on the globe model, our eye line is up here for this observation, eye level line. So obviously if this is on a globe, Soundly's got the camera or the telescope angle down by about 0.23 degrees, something like that. To get this in center frame. Yeah, that's the weird thing about the image, because the only thing that explains it is if it's stretched, but it was interesting because I found on Google Earth, where is it here? Make sure I'm sharing first. All right. On Google Earth, I found a second tower that's within like 0.01 of a degree in the direct line of sight as the first water tower. Actually, I think it's a water tower, and maybe it's just like a big sign, but where is it? It's considerably further back. It's like 50, 52, no, it's not that far back. 46 kilometers, I think, was the line. And I'll just show you this view. But it seems considerably taller than the other water tower, and it does have the more spherical shape to it. And it looks like see, it doesn't look like there's a whole lot of light. Well, maybe there's a Walmart right beside it, but it almost looks somewhat illuminated in the photograph, especially if you go to the actual video and watch it change throughout the video. There's times when it becomes really clear. But yeah, we can't be seeing this and not be seeing the first water tower because, like I said, they're both so close in the same line of sight that, like, I put these two lines to the extreme sides of each water tower just to see how much difference there is, and that's how much they're off by. So if anything, this water tower would be directly behind the first one, I guess. Maybe we're somehow kind of seeing both blended together. I don't really know. And I'll just show you since I'm on Google Earth, and over here I'll show you the large radio mast that I found, which is a very long skinny mast, and I'm sure it has a light on the top. You know, just comparing the shadow to the water tower, it's considerably higher than the other towers, and it's in the exact right location. This line runs right directly across the center of the first hump, which is, whoops, right here. Yeah, like the line literally runs through here. But like I said, our observer location could be a few meters either way within the hotel itself, which makes a minor difference on these really far objects, and a little bit of a difference on the overall field of view angle, just because I'm lining stuff up with the two kind of closer towers and the edges of the field of view. So yeah, like I'm just gonna go to, I'll show you the original video quickly. Hopefully Soundly won't mind. All right, I think I've got it up here. I mean, you can see it kind of waving around a bit. You can almost make out the writing, but it also, like, it just seems a little bit out of place size scale wise, even though it does kind of check out pixel wise, but yeah, it's interesting. And then watch for the flashing light up here. That's the other tower. Then we have our first tower. You can see flashing. It's kind of right behind the street light, but times you can definitely see a distinct flash there, and you can even make out a bit of the distant tower here. But it's literally, yeah, you see it there, flashing. And then this becomes really well lit for a brief time, and it does look vertically stretched, if anything. But I mean, this field of view is so small and so squished. That just that little bit of distortion makes it hard to tell exactly the true angular size. I should actually be using one of these for my photo comparison still frame where it's more visible. It's just weird because when I go to the end of this bridge, like say from this location looking on Google Earth, you know, this is just a speck on the horizon. Even if you zoom in a little bit, which you can do on Google Earth and Street View. Anyway, it's just another observation that's going to end up being somewhere down the middle. The thing about this one, though, is I don't think we can just apply, like, say that tower should appear slightly higher due to standard refraction, though, because, I mean, usually when we're saying that, it's because the object we're looking at is higher actual elevation, like regardless of, yeah, you're looking at it lower down than your position, But in terms of atmosphere layers, we're generally looking at objects that are above the observer height and therefore refracted down through the atmosphere and appear higher than they actually are. But in this case, we're looking pretty much eye level to the tower in terms of atmosphere level, or, you know, absolute level, I guess we'll call it. Absolute height. And therefore, light wouldn't bend down through the atmosphere at that angle. If anything, it would want to bend up and appear even lower through standard looming conditions where the atmosphere is getting denser with altitude. But I'm not sure I can explain it on a flat Earth model either. And I don't know if having a lower observation height, I know there's still some contention around that. Flat Earth Perth feels it should be more like 43 or 44 meters, I think. And a lot of people are arguing for 50 meters, and it really doesn't make that much of a difference, but the more numbers we can get exactly accurate, the easier we can tell. The concavity, what do you mean? So there's no difference if the observer or the target is higher. Light will be bent down or bent up in both situations. So you're saying it doesn't matter the like the observer height compared to the target on a globe model, basically? Right. Yeah. No, I understand that. But I guess it would be like, yeah, but okay, so that's where I disagree though, because I think that light that was exiting, so light being reflected off the target at we'll call it greater than 90 degrees relative to the surface, assuming the surface is perpendicular to the Earth. So you have above or below 90 degrees, any ray of light Yeah, okay, how does that work? Because if it's traveling up through the layers of atmosphere, but the atmosphere is becoming less dense as it goes up, then it would still be bending down, I guess. I guess that makes sense. So a scenario where light would bend upwards would be, well, basically where you had a more drastic increase of temperature towards the surface, probably in the last 10 or 20 meters, probably the last 10 meters more so, to get like inferior mirage conditions. And all you need for that in standard conditions. Oh, okay. I don't know. I guess it couldn't really. Yeah, no, like I don't know. I guess I have to do more modeling, but I guess the problem is whenever I do like the standard refraction on the globe model, it does make things appear slightly higher, but it's not consistent throughout the image. Like it doesn't bring back the bottom of the object as much as the top, and then if you increase the conditions, well, you've seen some of my demonstrations, but I don't want to do any right now because, well, maybe I could. I don't know. I was gonna shut this one down pretty soon. mean, I guess I just did build this to test observations, but the only thing is it's going to generate layers only to the top of the object, not all the way to the it should be generating layers above, since it would technically have to be rays of light that were shining, that were aimed above the viewer and then bending down from that angle, so they would be coming in from higher layers of the atmosphere, if that makes any sense. So this isn't really going to work, I can tell right now, but I'm just going to see what will happen anyway. I don't have that one set up to work for refraction. I mean, I don't know. These are standard looming conditions over 100 meters, and then we have our target 150 meters, so I guess I should use a target that matches height. So if we kind of look at these rays, see what they're doing. Oh, I know why. It's not even going. I think I have it stop scanning it. Oh no, it's scanning till it hits water. Anyway, what I should be doing is entering or using spreadsheets so I can get the exact values for the exact number of layers that I'm using. The date of that observation, though, I'm not sure. It might be on. Okay, yeah. 10th of December 2017. Yeah, it's funny how old this observation is, and nobody really challenged it except for Mr. Thrive and Survive, I think, was saying it's manipulated somehow or trick photography. I haven't ruled out the possibility that because he's shooting it through a telescope and then cropped by a camera, that could be picking up some of the barrel distortion of the telescope, but I don't know how considerable that would be. But it is a very narrow field of view and a really good observation. I mean, it's at least as good as what you'd get with a P900, right? 2000 millimeters roughly lens, I think. I made a video about P900 and the P1000 that got 12,000 views or something like that. I don't even remember the field of view or the focal length of each. Yeah, cinnamon control, if you can get the high altitude data, if you can somehow generate a spreadsheet with what you figure the refractive indexes would be over a certain number of layers, I guess we would need like I don't know, to see, at least to see to the top of the water tower. So, well, let's say 60 or 70 meters of atmosphere if we calculated the exact index of each layer somehow. I'm sure you could make a spreadsheet formula that could simplify that better than I could. But then I can load the values directly in. Yeah, and then I can also kind of see if my calculator is giving the results that kind of match what you guys think should be happening. So that will be a good step. I don't know if you can do that or not, but something like that would be really useful. And then I'll just adapt this so that I can set the layers above by however many meters and make it an extra point on the gradient. But like I said, the spreadsheet will just go off the number of whatever's on the spreadsheet, it'll draw. So if there's 100 values entered, it'll draw 100 layers. And 3.7 million rows of data. Does it pick index values in between the layers? Yeah, well, so far, like I've got it set up for three different points, right? And like I was saying before, if I could, it'd be nice to set it up so I could interpolate layers based on a curve, like a float curve. You know, so you could get the transition, because obviously the atmosphere is not always a linear transition from point to point of temperature. So I was trying to do that. I just don't really know how to scale it to work for refractive indexes. Yeah, I wasn't in the mood for that much math that day, so but yeah, I can interpolate. It'll do it linearly between 3 points, and I could easily adapt it to any number of points, but it'll still be linear for now. But you could give me a value, say every 10 meters, and then I can set it up so it'll automatically do the values in between. So I mean, ideally I would like to be able to just input temperature data directly into the calculator and have it calculate the indexes based on that. But that involves doing the entire formula or a series of formulas for determining everything from atmospheric pressure and humidity. And yeah, I don't even know where to start with that. So for now, I'm just going to leave it the way it is. And deal with a little bit of inaccuracy. But the basic principle, I mean, I know there's going to be some variation as far as like mirage effects that we're seeing, and that's caused by the position of the layers on the globe model. The flat model, it's not really as noticeable, but the globe model definitely it does make a big difference in the miraging, but it shouldn't matter for the overall lifting of the image or looming. So if we kind of ignore some of the miraging effects and assume that they would be smoothed out in a truly linear atmosphere gradient, then it should be accurate enough to at least demonstrate the overall effect of what's going on in the atmosphere. I've come to terms with it. Never going to be a perfect representation of reality, but I also don't think anyone could possibly, recreate the atmosphere over that distance accurately in any type of simulation or calculation. You're always going to have, way too many variables changing in real time to compensate for, so you have to just go with the average overall effect. Anyway, yeah, probably gonna wrap it up pretty quick here and try and put together a little video. Flat Earth Perth said he may be going to New Orleans or this area and take some observations for himself. I'm sure if he goes, he'll do plenty of observations while he's there and have a lot more data to work with. So whatever I do produce, I'm not going to say that it proves anything or make any claims, really. It's just kind of an exercise to see how accurately I can model things at this stage, and then once we get more accurate information, I can go back and see where I went right or wrong, and how I can improve my observations. And also I'll try and keep in contact with him while he's doing the observations, and then we can get specific things that we need, because there's lots of water towers, lots of radio towers further down the shore that could be seen, and be good to see them at different elevations, find out exactly when things start to be miraged, how low you need to be, etc. But now I'm just kind of babbling on, so I'm going to wrap it up unless you have anything to add to that. Cinnamon Control, if you're still here. Date? Yeah, I'll check again here. It's the 10th of December 2017 from the 15th floor of 3 Lakeway Center. Yeah, he doesn't say the time. December 10th. But, I mean, oh, he even shows the telescope he used and everything in the spreadsheet. And of course, Walter Bislin has modeled this. I'm not trying to suggest that his model isn't correct or anything. I'm just doing it for myself, and basically just his model so far doesn't include the water tower, so that's what this whole water tower gate is about. And there's plenty of better observations that I should be modeling as well, so I'm going to switch over to those. This will be my last live stream dedicated to this for now, but I am still going to finish that video tomorrow. I'll give you a minute to type. I gotta run outside for 2 minutes here. for December 10th, 2017. Oh, perfect. That's good. And I was just thinking about the about light bending up through the atmosphere under standard conditions. Like it wouldn't, but since it's traveling upwards through the layers of less dense atmosphere. Sorry, hopefully you can hear me. I'm kind of away from the mic for a minute. But if you're traveling up through the layers of atmosphere, at a certain angle, depending on the strength of the looming conditions, the rays would be bent, but at the critical angle they would still reflect, in which case you would have some evidence of a superior mirage, would you not? And I know how you feel about reflections and the critical angle when it comes to atmosphere, weather. Anyway, just give me a second here. Yeah, like I don't know. I mean, they must occur. I mean, how else do you get an inverted image if the ray doesn't, like, the series of rays doesn't basically flip? And the only way to do that is with a reflection. Yeah, I don't know. That's something that's open for debate, and I guess it depends what you consider a reflection, because technically if it bends enough that it's headed the opposite, like headed at an angle away from the normal, or away from the normal, then the angle it entered, technically that's a reflection in my mind. I mean, isn't that what causes inferior mirage or superior mirages to begin with, is when you have a considerably less dense atmosphere above? Yeah, like it's hard to call it a reflection because when you think reflection, you need like a specific layer or surface, but the reflection would happen on a slightly different layer for each specific ray, I guess. And that's why you get inconsistencies in the, some slight stretching of the ray, but I think that has more to do with the gradient of refractive index between those layers, more so than the changing angle of the normal as a result of the atmosphere on a globe model, which I've seen people try and argue that that's what causes the compression of the mirage on a globe model. So I can't really visualize that yet. I don't know. I'm gonna keep this running for another 10 minutes or so, because otherwise I'll be compelled to work on my video, but I probably should go to bed after this. Oh yeah, cool. I'll check it out right after I'm done. I got too many things going just at the moment. So I mean, I guess I can get a pretty good idea of, see, the other thing is, Soundly has his center of frame at, the middle of the target, not anywhere near the line of what would be the line of convergence of the roadway, of the bridge, which for whatever reason right now I can't get my my angle is really insensitive, or whatever, too sensitive. I can't get the exact angle that he's using, but it's almost like this, like he's looking right off the screen. Anyway, I'll try and match his observation a little closer. And then I can show the difference. Let's just say that radio tower is at so what I need is a save button, because I can load observations. I'm going to work on that tomorrow. I'm going to make it so I can save and load observations, and then I can map them out in here, save them to a spreadsheet basically, and then load them up, and then I can spend some time making more complex scenarios. So that would have been at, like, the far one would have been 53 kilometers, I believe. And this is right now scaled to 100 meters. I'm sharing the right screen yet. So, I mean, if that tower is 100 meters tall, which it very well could be, close to that, maybe 80 meters, somewhere in that range, then it lines up pretty good with the flat Earth model. Of course, we don't have an accurate number for that tower. So basically that's this here. This light up here, and it's roughly the height of the tower above the tower, a little bit less. So that would be a good indication that it's a 100-meter radio tower and with the increased distance away, it's dropped slightly. That's what we have. On the globe, well, on a globe, that's got to be a really high tower. Or we have to have some really strong looming going on. Yeah, because the hidden, let's just check that quick. I'll just put it on my stream so people know I'm not making it up. So I have the viewer height at 51 meters, and we have 60 meters hidden, but if that was actually a 100-meter tall tower, the ground elevation at that point was 10 meters, so we knock this down to 50 meters hidden, so roughly half the tower hidden on the globe model. And that's about all I can say for that for now. I don't know how tall the tower is. I'm just guessing based on, well, first of all, based on the appearance in the video, that it should be roughly twice the height of the tower on either model. I mean, it should appear twice the height. But then if I'll show you the tower again on Google Earth. It's considerably taller tower. Here, I won't change the zoom. And I'm just going to measure roughly. Actually, maybe I was looking through different images. It's really hard to get an idea or to get an accurate estimate because of the trees, but I mean, we could say safely that it goes from here to here. Anyway, it might go further, like here. Well, let's just say it's here. So that's a 64-meter shadow. And then we'll go over to our first water tower. measure this, something like this. So, I mean, it's hard to tell where the top of this object shadow really would be because of the ball shape at the top. But, and I was very low end, so yeah, it's probably not even twice as tall. You know, it might be 80 meters, might be 70 meters, but it's definitely taller than this based on the shadow. I mean, that's 60 meters to there, but if this were just a pole, then I think the middle of the shadow, I'm pretty sure that's the way it works, would be about there. So I'm sure there'll be some contention around that if I make a video based on that, so I'm not going to claim to know the height of the tower, but if anyone can identify this tower and confirm that that's what we're seeing. I mean, I looked pretty thoroughly through this whole area. I spent way too many hours on it, and this was the only significant tower that I could find. And of course, these shadows also depend on the sun angle, so I can't really tell anything from them unless I keep going back and comparing to the supposed known height of 51 meters for the other shadow. Not much good imagery past 2007, 8, 9. Anyway, I mean, Soundly's method of, I don't know if you saw his live stream, Cinema Control, where he showed how to triangulate, get the length of the shadow, or the height of the object based on the length of the shadow and the elevation angle of the sun, which is quite simple, but I actually never thought to do that, to calculate anything. But I mean, it's not entirely accurate unless you can get a perfect match for the angle of the sun, and I guess you can get it fairly close. That's a good point too, yeah. Imagery is stitched together. So, I mean, Soundly did say if you're going to measure that way to get, you know, to do multiple scenarios and get an average, but with that tower, it's hard with the trees to even find the end of the shadow. So, it's basically just a guess right now, but basically, if I'm going to make any claims that those are the 3 lights we're seeing in the video, I have to identify those 3 towers, make sure there's nothing else those lights could be. The only thing is, as I just showed on my model, if that is the tower we're seeing really far back, it needs to be even higher than 100 meters for it to work on the globe. And it needs to be less than 100 meters for it to work on the flat Earth model. So, anyway, I've been at this for 2.5 hours. Using the headings like, sorry, the line angles from the observer location. Is that what you mean? Because when I did that I'll just show you since I'm on Google Earth anyway. Should be around here. So the line of sight for the far tower that I was just showing crosses over the first large hump, which isn't actually a large hump, but it appears that way from the angle of view. But we can see it basically passes over the apex of the bulge, kind of right off to the side. I think, yeah, that's the right line. So the apex of the bulge kind of right in the middle of this would be the left lane looking at it in the image, and I'll just show the image here. Yeah, our far tower location is, the light is right here. And when I calculate the angle between this line and, where is it? This tower here. So we have a flashing light here, flashing light here. When I calculate, well, when I measure the angle, where was it here? So this angle, pixel-wise, works out to our angular size of this entire width. And to measure that, I lined it up with this point and this point running through the third shed, basically right on the corner of the third shed. So if that point and that point line up, this point and this point line up, and my center tower lines up, and then also the angle between this and this, I don't think I've checked both sides. I think I just checked between this tower and it worked out. So I'm gonna double check, triple check all those tomorrow as I'm making my video, and just you know, got to be as thorough as possible, even though I've spent way too much time on this one silly little observation that's probably not going to prove anything either way, but it's still a good exercise in determining what we're actually seeing here. So yeah, no, I basically did. The thing about the bridge, though, is because we're seeing, you know, fairly close on the bridge, like these first few sheds are only 6 or 8 kilometers away from the hotel. So if I even move the actual viewer location from one extreme to the other side of the hotel, that changes the angles to these. Like, it doesn't change them really. I guess it changes them proportionally, but it changes the angle to the outside images in relation to the towers. So, but you can basically see on my oops, where these lines converge is a pretty good estimate of where Soundly was. If he actually comments or says Yeah, basically I had him in the center of the hotel. I mean, he could have been further over this way, and I mean, that's why I'm not putting too much faith in, but I mean, there's only so many things those lights can be, and if we are seeing those two lights from the two closer towers, then that's a pretty good way to get the angular size scale and convert that to pixels. And then if everything else works out, then it's a pretty safe bet that his location is within here. I don't think he's way over here, and I don't think he's way over here. He probably had a fairly straight on view. I mean, if he went there to specifically do this observation, he would probably want the best view possible. And I mean, the 15th floor, he should have been above this building. He wouldn't have been looking through it. But like I said, he could have been over here. I don't really know. I'm not compelled to research every last bit of this. If anyone wants to comment and let me know where he actually was, I'll gladly update my numbers. So oh yeah, for your planes one, yeah. So it confirms the expected amount of drop on a globe model, obviously. Is what you mean? Yeah, and the only reason I haven't said much about that observation and test that you did is not because I doubt what it shows to you, but yeah, but I just I don't know. I got to stick with things that I can observe and prove to myself. But definitely, I think it's a good observation, a good test. I don't know if I'd call it a experiment, but Nathan Oakley's standards, but definitely a good test that confirms what you think. So anyway, I'm gonna shut it down, but thanks for hanging out. You were pretty much the only one in the stream the whole night. That's okay. I got a few things done, a few things demonstrated. I might just timestamp a couple of things in the comments, and then maybe I'm going to start doing that for these longer live streams in case there's anything important that I talked about, so people don't have to sift through 2.5 hours of a lot of dead air. But yeah. Anyway, thanks, Cinnamon Control, and I'll talk to you soon.